Alright, so we're going to be doing problem number 2 here on the CDEN 3256 Construction Engineering Exam 1. You can see here that we're looking for clearing and piling with grubbing, total cost and duration in hours. So to get started here, we're going to go up to the problem, highlighted most of the key information that we're going to be drawing from for this problem. So we can start in multiple places on this problem, but we're just going to start and just get this labor rate all settled, and then we'll come back to that. So we're going to find the loaded labor rate. So you see up there that it says 30 per hour, but we have to adjust that appropriately. So if you remember, labor is equal to the base rate, and then we have to add workers' comp, and we have to add this EMR factor for their safety record. Okay, so doing that out, this is going to be equal to 30, which was the base rate, times it's increased by 23%. You can see here 23% of the labor costs, so we're going to multiply by 1.23. And their EMR from right here is 1.1. So that comes out to loaded labor rate of $40.59 per hour, and that's per operator as well, so for one. So we'll keep that in mind for later. Alright, so next step is to actually find the time required to clear, grub, and pile. So we're going to start with clearing. Okay, so if you remember the equation for clearing, it is in here. So we have, we're going to start with cutting, and that's this equation right here. So this H, A, B, M, N, M, N, D, F. Okay, and right here you can see that we have B, we have M1, M2, M3, M4, and F all come from the table. And N1, N2, N3, N4, and D come from the problem itself, the statement right here. So these are all the N values right here. So the only thing is we need to look at the problem to get the right column, and it's a 335 horsepower tractor. So looking in this chart, 335, we get these numbers. So B, 18.22, M1 is 0.2, M2 is 1.3, 2.2, 6.0, and 1.8. And this is for felling, which is cutting. Okay, so using that equation and that table and the information from there, we get, remember H is the hardwood factor. Hardwood factor, you can see they put right here, 75 to 100%, add 30% to total time. So we should go back to the problem, which is right here, and going back up here, greater than 75% hardwood. So H, we're going to put it way out in front. We're going to increase by 30%, so 1.3. Then AB, we have 2 is our A, which is the tree density, which is also right here. Tree density, dense is greater than 600, so on and so forth. You double the time. So if we go back to the problem, 700 average trees per acre makes our A 2. Alright, so B is the base rate from the table here. B for 335 is 18.22, so put that in, 18.22, and then M1, N1, and I'm just going to put these in. I'm going to trust that you can find them in the charts. 0.2 times 80 plus 1.3 times 30, and that max one, M3 is a 0, but it would be 2.2 times 0. Okay, then we have 6.0 times 8, and then DF is 2.2, but then that's times 0 as well. Oh, I'm sorry, that's 1.8. 1.8, but it's 0 anyway. Okay, so all of that, multiply that by that 1.3. So we get a 181.27 minutes per acre. Okay, so we need to adjust this for grubbing. So grubbing, if you remember, is just a 25% increase in time if done in one operation, which is what this one is. So adjusting for grubbing. We get 181.27 times 1.25. And that equals 226.6. And that's minutes per acre. Okay, and that is per dozer. So if we want to get a rate for 3 dozers doing this, you can imagine each one of them splitting this in thirds to work simultaneously. So then, so total, so for 3 dozers, the time is 226.6 divided by 3, and that's going to equal 75.5. Alright, so we did clearing, grubbing, let's do piling. Okay, so piling is a similar equation. B plus Mn, dF. The only difference really is that you need to pull from this other chart. Okay, so here's 335, here's your new B, your new M's, your new F. All your N values stay the same. So going ahead and plugging in all those values, assuming you can find them in the chart, is B 44.94 plus M1N1, in this case it's 0.1 times 80, plus 0.5 times 30, plus 1.8 times 0, plus 3.6 times 8, and then our dF is 0.9 times 0. And that comes out to 96.74 minutes per acre. And then we're also going to adjust this due to the grubbing in one operation. So again, 96.74 times 1.25 gives us 121 minutes per acre. And again, that's just for one. So for 3 dozers, we get 121 divided by 3 is equal to 40.3 minutes per acre. Okay, so next step, now that we have these two numbers, here and here is to find the total time and cost. So we're going to do total time and cost. And so we have the clear plus the pile equals 75.5 plus 40.3 gives us 116 minutes per acre. Okay, and so our total time then is, if this is minutes per acre, we just have to multiply it by the number of acres to get the number of minutes. So our total is going to be 116 minutes per acre times the number of acres, which is 27.25, and that comes from the problem. 27.25 acres of land must be cleared, grubbed, and piled. So that's where that comes from. The acres cancel out, and we're left with 3156.6 minutes. Okay, so in order to get cost is in hours per operator, so we need to get this into hours. We just take this number and divide it by 60. Divided by 60 minutes in 1 hour, and we get 52.6 hours. So you can round that to 53 hours, and there is the total time. Okay, and then the cost is just as easy as it sounds. Now that we have the time, to go 53 hours times the base labor rate, which was 40.59 per hour per operator, times the fact that we have 3 operators. So this is in hours, the hours cancel, the operators cancel, and we're left with dollars. So that comes out to $64.53, so $6,453.81. And there is your solution.